Okay, so an article in a journal reports that 34% of American fathers take no responsibility for childcare. Deadbeat dads, they call that, right? A researcher claims that the figure is higher for fathers in the town of Littleton. A random sample of 225 fathers from Littleton yielded 40%, wow, who did not help with childcare. It's terrible. Find the p-value for a test to support the researcher's claim. Round your answer to 2 places. All right, another hypothesis test. You know what we do. First step, claim. Got to start with the claim. Always start with the claim. So what is being claimed? A researcher claims, they even use the word, that the figure is higher for fathers in Littleton. So what am I going to write there? Is this a P percentage or a U for mean? Mu for mean. Which one is it? P percentage or U mean?
Percentage.
Yeah, clearly percentages everywhere, huh? So P is, what am I going to write? It's being claimed.
The claim would be, so it's higher. So would it be like it would be higher than, what's it called, 3 or 34? So it would be,
Right.
I don't know how to say it, like.
So P greater, yeah, you're right. P greater than 0.34. Yeah, higher, greater, bigger, right?
Yeah.
Good, exactly. Does everybody see that? That's exactly right, right? Because this journal said it's 34% for all of America, and the researcher thought it was higher in Littleton. I guess that's what the researcher's claiming. Greater than the national average of 34% in Littleton. That's the claim. All right, so let's write the HO. And let's write the H1. What's HO always?
Equals.
Always, right? Getting good with that. Always. Oops, my little pen thing's not working well today. I'm not sure what's going on with it. There's a bunch of lag to it. Always equal. So always equal. And then one of these two always matches the claim. It's not HO, so it's got to be H1. Does that make sense? And write claim there. One of those two is always the same as the claim. Remember that. Let that be a solid rock in your mind. One of those two, either HO or H1, always matches the claim identical. One of them is the same as the claim, always. No exception. So in this case, it had to be H1, right? Because HO is always equals, and therefore H1 had to match the claim, okay? And then we write weak evidence for HO and strong evidence for H1. And then let's do the problem from here. So we're going to go to our calculator. So if you look at the notes, we're doing a P, hypothesis test for P. So let me go find that with you. Ooh, I went too far. All of a sudden it flew along. There it is. Hypothesis test with your calculator. It's P percentage. It's not mean on this one. So it's a 1 prop Z test. There it is. We go back to the 1 prop Z test. Back through all these other problems here. Where am I? There I am, right there. Okay. So we're going to do 1 prop Z test. So hit stat. Go over to test. You guys are pros at these now, right? We've gone to this menu so much. So hit stat, go over to tests, go down to 1, or what number is it? Yeah, number 5. number 5, which is 1 prop Z test, and hit enter. Hit enter, and when you do, you'll get the various options, which are P0, P0, X, N, and then the proportion statement. Okay, so what is P0? That's always the number by H0. We know that. 0.34. X, what's X on this one? X is always the number being asked for. What number is being asked for? Oh, that's a tricky part on this one, isn't it?
Would it be?
But we do N. N is always the total, huh? We can do that. What's the total in the sample?
225.
Yeah, 225. Right there. Good. Yeah, but what's the X? That's kind of tricky, isn't it?
Would it be 40% and you change it into a decimal?
Well,
225
it's got to actually be, it's not going to be a percentage. Yeah, in the chat, Coda's got it right. It's 40% of 225. Yeah, do you see what they're saying? So notice you got to take 0.40 times 225 on your calculator. Why? Because it's 40% of the 225 people. That's what they're saying. Is that, am I losing you completely on that one? So that would be 90. I think it's 90, isn't it?
Yeah, when I put it in, I put 40 times, 0.40 times 225, and it just put 90.
Oh yeah, right. You can totally, yeah, I like that. Thank you for pointing that out. You can totally just type that in right there. Yeah, thanks. You can just totally type 0.40 times 225 and let the calculator do the work for you. Yeah, exactly. Just type that in and it'll make it a 90 for you automatically. Yeah, now the real trick for most people is, how do you know you're supposed to do that? Let me help with that for a minute, because I know this is the kind of thing that fools people and tricks people. Whoops. I don't want you to get fooled or tricked by this. So let's talk about it. How do we know it's that? Well, what the X and the N are is there for the sample. You know, for the sample we did, X is the number that they're talking about. Now, what are they talking about in this case? Deadbeat dads, right? Dads who don't, did not help with childcare. So in other words, out of 225 total dads in the study, the sample of 225 fathers from Littleton, 40% of that sample were dads who did not help with childcare. Well, how many is that? 40% of 225, 40% times. Remember, of is times. Remember how of is always times. When you read of in a word problem in math, it's times. So 40%, 0.40, change to decimal, of times 225. So 40% of that group, just under half of those 225 dads, that is 90. So put in 0.40 times 225. Calculator will make it 90 for you automatically. 90 out of the 225 dads in the sample were deadbeat dads, dads who did not help with childcare. So that's a little tricky, isn't it? Normally, they just hand us this number, don't they? Normally, they just directly tell us, they go, 225 dads were surveyed and, 87 of them didn't help with childcare. But this time, instead, they gave us the percentage. So we have to figure out the number ourselves. 40% of 225. So remember, this x here is the number asked for. Now you might say, well, how do you know, Mr. Heron? How do you know you're not supposed to put in the 0.40? It's never a decimal or a percentage. X and N are never, how do you know? Well, because P0 is a decimal, right? It's a P. But X and N are never percentages. So maybe you could write yourself a note on your exam 3 notes. X and P, never a percentage. So here's what I mean. Like, that's why I say you can add to those notes whatever is helpful to you. So like, if you're afraid you're going to maybe get that messed up on the exam, what you could do is you could come in here and say, okay, right here, this is never a decimal. These guys are never decimals because they're a number of people. Can't have part of a person. All right, whatever is helpful to you. All right, so on number 11, let's finish it up. The proportion, you know what we do with that, that's always the same. Same as H1. Boy, my pen is not happy today. Same as H1. What's H1? Greater than. So choose greater than there. All right, I'm going to put all this into my calculator as well. See what we get here. Hit calculate, and I'm getting a p-value equal to 1.8999.
1.8999 was my Z.
Yeah, that's my Z.
Oh, you're right. Just kidding. I was testing you again. I'm always doing that. Thank you. I'm just getting tired, not looking carefully here. I know I was looking at the answers going, man, I'm way off. All right, 0.0287. So which answer is right?
0.02.
It round.
Oh, 0.03.
We're all
Yeah.
rounded to 2 places, right? So we'd have to round to 2 places. So it'd go to 0.03, right? Everybody good there? So you have to round, because again, I don't want you to be confused by that. Students have asked me in the past, Mr. And I don't know about the rounding. You don't tell us how many places round. Well, I do tell you because I show you the answers, huh? So just do whatever the answers are doing. They're all rounded to 2 places. So therefore, you round to 2 places. So that 8 rounds us up to 0.03. Does that make sense there? So there's the p-value.